Hello friends, today in this session we will discuss Chi-Sqaured test, and this is a statistical hypothesis test which is used in the analysis of contingency and frequency tables. The Chi-Sqaured test is used to determine the goodness of fit of a distribution, how a model compares to actual observed data, but important point is the data used in calculating the chi-square must be random, raw, mutually exclusive, drawn from independent variables, and drawn from a large enough sample. This is often used to test the hypothesis that the given data follow a particular distribution. The equation to calculate chi-square is given here, summation of observed frequency minus expected frequency whole square divided by E. So you can see here that this equation is not dimensionally balanced, and therefore it can only be used on numbers and proportions or frequencies only. Chi-square test is used as a test of significance when we have data that are expressed in frequency or data that are in terms of percentage of proportions and can be reduced to frequencies. It cannot be used on data where you have a unit like millimeter or gram or kg, because this is not dimensionally balanced equation. Let me explain how this chi-square test can be used in different situations. The first example is that you consider a case of imaginary coin with exactly a 50-50 chance of landing heads or tails, and a real coin that you toss 100 times. So there will be a difference in the imaginary coin and the real coin. So if the coin is fair, then it will also have an equal probability of landing on either side. And the expected results of tossing the coin 100 times is that heads will come up 50 times and the tail will also come up 50 times. Now that is the situation where you expect from tossing a coin. But actually, when you toss a coin 100 times, the result is like this, that head 42 times and tail 58 times. Now the question is whether this coin is fair enough to believe that it has the equal probability of landing on head or on tail. So we make two hypotheses here. That the null hypothesis is that the coin is fair. That means there is no difference between these two values. And the alternate hypothesis is that coin is not fair. So this is the table we prepare, that for heads the observed frequency is 42, for tails observed frequency 58, but what we expect in a fair coin is 50-50. So if you take the difference of these two values, you get observed minus expected. Take the square, divide by expected value, that gives you the chi-square value. You take sum of these two, that is 2.56. Now, how do we say that this 2.56 is reasonable or acceptable or not? So for that, you enter into the standard table of chi-square with some degree of freedom. Now here D is a degree of freedom and this is the level of significance, alpha. So if you take alpha 0.05 and degree of freedom 1, because there are only two rows, so degree of freedom will be rho minus 1. So degree of freedom will be rho minus 1 into C minus 1. So that is 2 minus 1 into 2 minus 1, that is 1. So for 1 degree of freedom and alpha is equal to 0.05, this value is 3.841. And this value is larger than the calculated value. So null hypothesis is accepted that the coin is fair. Now let me explain this again with the second example where you have some before and after study data. Let us say you have an intersection and there are number of accidents on intersection before improvement and after improvement. So let us say B is the before improvement and A is the number of accidents after improvement. Now if there was no effect of improvement, then let us say that the expected number of accidents will be B into C. Now C here is control ratio. That is the rate of change of accidents per year, you can say. So in that case, this chi-square value is calculated by this equation. A minus B into C whole square upon A plus B into C. So here null hypothesis is that there is no real change due to improvement. That is the null hypothesis we make here. So if you take some data, let us say on a junction there were 12 accidents in a year, and after the junction is signalized, the accidents dropped to 8 per year. Assuming that the accidents on the junction increases at the rate of 10% during the period covered by the above two observations, test whether signalization has reduced the crashes at 5% significance level. So if there was no improvement in the accidents, these 12 accidents will increase at the rate of 10% per year. So that is the value of C. So null hypothesis here is that there is no real change in the number of crashes per year due to improvement. So A is 8, that is after the improvement, B before improvement 12, and C is 1.1. So with that, if you calculate chi-square value, you get 1.23. So again you go to table at 5% level of significance and degree of freedom is 1. So that value is 3.841. And now this value 3.841 is more than the value which is calculated, and therefore we accept the null hypothesis that there is no real change in the number of crashes per year due to improvement in the intersection. So signalization has not changed the number of crashes per year. One of the most common use of chi-square is found in so-called 2 by 2 table. This table shows yes and no response of two groups of people to an item in a questionnaire survey. And this is called the contingency table. Contingency table of 2 by 2, where you show the response in yes or no. So there are total 136 people which were questioned, and these are divided into two groups, group 1 68, group 2 68, and this is their response. So that is the total. 90 said yes and 46 said no. So based on that, if you assume that the difference in option is only by chance, so expected frequency or expected yes and no will be equal. 45 people will be saying yes out of 90 and 45 in group 2. Similarly, out of 46 people who said no, there will be equal distribution in two groups. So that is expected frequency or expected response. So based on that, you calculate what is chi-square value, that is 40 minus 45 square upon 45, that is the first one. And similarly, you have 4 values here, so you calculate 4 values here and take sum of all these, you get chi-square 3.285. Now degree of freedom here again, r minus 1 into c minus 1, that is number of rows minus 1 into number of columns minus 1, that is 1. So if you enter table, it enter table at alpha is equal to 0.05 and degree of freedom 1, you get the table value 3.841, which is larger than this value. And therefore, the null hypothesis that there is no real difference in opinions of two groups is accepted. But many a times it so happens that you do not know what is the expected frequency or what is the expected response. So in that case, when expected frequency is not known, if you take this table and you label them A, B, C, D like this, and let us say M and N is a total number of yes and no, and grand total here is sample size 136. So in that case, you can calculate chi-square value using this equation. N is total number, A into D minus B into C, that is the cross multiplication, divided by KLMN. Now K is here, K is 68, L is 68, that is the total of group 1, total of group 2, but mind this is total number of yes, total number of no. So if you calculate this chi-square value 136 into 40 into 18, that is 40 into 18 minus 28 into 50 whole square divided by 68 to 68 into 90 into 46, you get 3.285. And this value is exactly same what we calculated earlier. So that is how you can determine chi-square without preparing expected frequency table also. But if you are required to prepare this expected frequency table, then how do we prepare it? So let us say you have a 3 by 3 table. A, B, C, D, E, F, G, H, I. These are the observed values in these cells. And if you take the sum of columns here, that is M and P, sum of rows here R, S, W, and this is the grand total T, a total of all 9 values here. So this expected frequency can be calculated like this, that this value here in this cell A, in the cell of A will be this. A is governed by M and R. So M into R upon T, that is the expected frequency for this. Similarly for this, N into R upon T, and this is P into R upon T. The next table will be M into S upon T, NS upon T, PS upon T, and so on. So that is how you can calculate expected frequencies. Let me take one more example just to illustrate the procedure of using chi-square test for testing the fit of a distribution. Suppose you have headway measurement on a section of highway, and these are the results. You have a frequency table here. For headway range of 0 to 2 second, there are 120 vehicles. 2 to 4 second, there are 108 vehicles. And you assume that these data will follow the negative exponential distribution. So let us first fit these data into a negative exponential distribution. So what we do here, you add 2 more columns here, take the midpoint of the headway range 0 to 2, 1, 2 to 4, 3, and so on, and the frequency here F, this is I. You calculate 120 into 1, that is 120, 108 into 3, 216, and so on, and that is the total sum of Fi, Hi. So with these values, you calculate average headway, summation of Fi into Hi upon summation of Fi, that is total number of frequency, that is 373. So you get a average headway of 3.47 second. And that is the equation for negative exponential distribution. That is probability of headway less than or equal to T is 1 minus e to the power minus q into T. Now q here is the rate of arrival, which is inverse of this average headway, 0.288, and therefore you can write this equation that probability of headway being less than or equal to T is 1 minus e to the power minus 0.2888 into T. Now you calculate the probability for T is equal to 0, 1, 2, 3, and so on. So these are the midpoint of headway range. So you calculate the probability for each of these headway. And we go to the next page. Now this is the probability of headway being less than or equal to T using that equation. And if you multiply these probabilities by total number of frequency, observed frequency, you get here cumulative frequency. So if you subtract these values, 93 is taken 93, and this value is 216 minus 93, that is the frequency for a headway range of 2 to 4 seconds. So this is the expected frequency, and this is now the observed frequency. Using this equation, you can calculate chi-square value, and that is the chi-square value for each row. Take sum of all these values, that is 10.785. Now degree of freedom in a frequency table is number of rows minus 1. So there are 7 rows, so degree of freedom will be 6. And if you take alpha 0.05, you enter this table for degree of freedom 6, and alpha 0.05 you had 12.592. Now this value is more than the value calculated here. Now since chi-square calculated is less than chi-square tabulated, so accept the null hypothesis. So accept the null hypothesis. That means the data follow the negative exponential distribution. So that is how chi-square can be used to determine whether the data follow a particular distribution or not. So in summary, it's a 5-6 step procedure. Create a table of the observed and expected frequencies. Use the formula to calculate the chi-square value. Find a critical chi-square value from the table using a chi-square table or statistical software for a particular degree of freedom and level of significance. And then compare these two values to find out whether the calculated value is higher than tabulated value or otherwise. And then you reject or accept the null hypothesis. The limitation of chi-square test is that it cannot be used on percentages. You have to convert that into frequencies. Data must be numerical and dimensionless. Categories of 2 are not good to compare. And the number of observations must be more than 20. And the test becomes invalid if any of the expected values are below 5. Now this point is important. Here, suppose you expected frequency here in any of the rows comes less than 5, then you should not use chi-square value. In that case, you add 2 rows to get a value which is more than 5. If it cannot be with 2 rows, add 3 rows to get the value which is more than 5. And similarly, you will add values in observed frequency table also. So friends, thank you very much for watching this video. I hope you liked it. You can write your suggestions in the comment box.